Okay, we're back. This is Math 200. We're looking at 6.5, Chapter 6. The last section in Chapter 6, polynomial equations. So finally, you get to, it's revealed why you learned how to factor. And factoring and solving equations is what this one is all about. So we're looking on page 14 on the note packet. And if you take a look, they have this up there. And this is interesting because it goes back to a property that you've learned a long time ago. 0 times anything is 0. So remember, if we took 17 times 0, that was equal to 0. Well, that is an if-then statement. If I multiply by 17, then I get 0. But not only is it that, it's called a biconditional. That means it goes the other way too. If I end up with 0 through multiplication, then one of the factors being multiplied has to be 0. So it's called an if and only if. If you were in geometry, you'd probably hit that, if and only if. That meant a biconditional. That means it goes both directions. If this, then that, but if this, then that. All right? So using that logic, if I have a binomial times a binomial and it's equal to 0, the only way that I can get 0 as a result through multiplication is if either this is a 0 or if this is a 0. So we literally just set them both equal to 0. You set that binomial equal to 0, that binomial equal to 0, and now you solve. And this is what we did way back in the first chapter where you learned, like chapter 1 and 2. So we add 4 to both sides, isolate the variable, x is equal to 4. We subtract 2 from both sides, isolate that variable, x is equal to -2. So -2, I put it in there, -2 plus 2 is 0, -2 minus 4 is -6, -6 times 0 is 0. I pop 4 in, 4 minus 4 is 0, 4 plus 2 is 6, 0 times 6 is 0. These are the two solutions. Fundamental theorem of algebra says if I give you a second degree equation, you find me 2 solutions. If I give you a third degree equation, you find me 3 solutions. If I give you a fourth degree equation, you find 4 solutions. And then there's all these kind of fancy rules that go along with that, but that's the basis of it, okay? So now, let's look at this problem. Solve. Well, I don't want it equal to 24, so we're going to move that over. Again, that goes back to chapter 2, isolating. We want it equal to 0 because of that 0 property stuff. So we want to get it equal to 0 for right now. So now I factor. This is a second degree equation. I want to break it down into a first degree times a first degree like this one, and I can do this trick. Okay? So we look at the -24, the suspect list for -24, -1 and 24, -24 and 1, -2 and 12, -12 and 2, -4 and 6, -6 and 4. I think that's everything. Oh no, -3 and 8, -8 and 3. All right, that's everything that multiplies to give you -24. This one is the one that adds up to -5. So we break this into a binomial times a binomial. X times x gives me x squared minus 8 plus 3. That gives me -24 when I multiply and -5 when I add. All right, so that is factored. So now we make this look like that original one was given, and we just go this one more step. Again, I've had students say, do I have to show this work? I know it's +8 and -3. No. The answer is no. You can factor it and just give me my answers. That's fine. I'm going to show the work just so everybody sees where the +8 came from and where the -3 came from. So those are your 2 answers. You can put those back into the original. If I go 8 times 8, that's 64, minus 5 times 8 is 40. 64 minus 40 is 24. I could pop -3, and -3 times -3 is +9. -5 times -3 is +15. 9 plus 15 is 24. So both of those work back in the original equation. They always will. All right. Let's do one more. factor and solve, and then we'll look at a couple of word problems. So this was kind of the reason that we learned how to factor, so you could bust things down from a second degree into first degree equations. So look, like this one. This is a third degree equation. That means there's 1, 2, 3 solutions. Fundamental theorem says if I give you a third degree equation, you find me 3 solutions. So I can, greatest common factor out the 3x. So 3x will come out of there, 3x will come out of there. And that'll be x squared minus 4. But now I can factor again, right? That's a perfect square minus a perfect square. So the difference of 2 perfect squares, bust that down into x and x, 2 and 2, plus and minus. So now be careful with this. This is a little tricky. We're going to set 3x equal to 0. We're going to set x plus 2 equal to 0, x minus 2 equal to 0. This one's easy. Add 2 to both sides, and we're done. X equals 2. This one's easy. Subtract 2 from both sides, x equals negative 2. This one, you divide both sides by 3, and 0 divided by 3 is 0. So 0 works, negative 2 works, and 2 works. So you can put it back in. 0 cubed is 0, times 3 is 0, 12 times 0 is 0, 0 minus 0 is 0. Works. Negative 2 times negative 2 times negative 2 is negative 8, times 3 is negative 24. And negative 2 times negative 12 is positive 24, and negative 24, positive 24 is 0. 2 times 2 times 2 is 8, times 3 is 24, negative 12 times 2 is negative 24, 24 minus 24 is 0. So all 3 of them work. But this tends to mess up students a lot. In my career, bunch of students accidentally put negative 3 because they're kind of falling into that. It isn't plus 3. It's times 3. So you divide by 3 and it's just 0. All right? So careful when you factor one out like that. Okay, so now on the next page, they already did, let's see, 2 consecutive integers. So you got to be careful if they sneak in the word 2 consecutive odd or 2 consecutive even integers, then it's x and x plus 2. If it's just consecutive integers, then it's x and x plus 1. And they've got that kind of written down. So when we translate that, the product means multiply. So when we set it up, it's x times x plus 1 is 132. It says the product of 2 consecutive positive integers is 132. Find the 2 integers. So positive integers, they threw in that word positive. That's going to change, that's going to make us throw away some of our answers. So now look, now I've had students say, oh, it's factored. I'll just say x equals 132 and x plus 1 equals 132. It doesn't work that way. You can't do it that way. It's got to be equal to 0. For right now, we're equal to 0. So we do the distributive property. Isolate, let's get it to 0. So subtract 132 from both sides. So now you've got x squared plus x minus 132 equals 0. Now, negative 132 is not a walk in the park. Negative 1 and positive 132, negative 132 and positive 1. That's obviously not it. Negative 2 and 66. Oh, boy. Negative 66 and 2, that's not it. So think of things that go into 66. Well, that's 6 and 11. So negative 6 and, oh, what is that? 20, 12, 2, 22, right? 12, carry the 1, 12, 13. Yep, and negative 22 and 6, that ain't it. What else? We got the 2. 22 has 2 times 11. Let's do 11. Negative 11, there it is, times 12. And negative 12 times 11, but we want this one because that adds up to 1. So winner, winner, chicken dinner. We're not subbing it in. It's not the AC method. It's the leading coefficient of 1, so just unfoil factoring. So it's x minus 11, x plus 12. And now look at what happens. X minus 11 equals 0. X plus 12 equals 0. And so we get positive 11 and negative 12. Only they stated they wanted positive integers. So that means this negative that we found, we're going to throw away because it's a negative integer. So 11, if x is equal to 11, x plus 1 is equal to 12. So 11 and 12 are the two positive integers consecutive that multiply to be 132. All right. Now, some of you might have said, no, but negative 12 and then x plus 1 would be negative 11, and negative 12 times negative 11 is also 132, positive. It is. All of that is true, except they stipulated they only wanted the positive answers, not the negative answers. So that's why those are garbage. All right. Okay, let's do the last one. Ooh, last one is a tricky one. Number 16. This is a whopper. Let's take a look. We're in the note packet, page 16, chapter 6. And so we got a right triangle. A squared plus b squared equals c squared. But now it says in a right triangle, the sum of the squares of the lengths of the two legs. Okay, yeah, we got that. Find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg. Okay, so here, shorter leg is x. Longer leg is x plus 10. But they went with the hypotenuse is 10 miles less than twice the shorter leg. Ugh. 10 miles less than twice the shorter leg. That's 2x minus 10. The hypotenuse. We're going to have to find all three of those in our answers. So this is, it doesn't look bad like this. It wouldn't be bad if they said perimeter, but they didn't say perimeter, okay? So they didn't give us, like, if they would have just said, and the perimeter is 100, then we'd just say this plus this plus this is equal to 100, and then we'd add them up and, you know, isolate the variable. It'd be easy peasy, comparatively. This is not easy peasy, because now we're going to take this leg and square it, this leg and square it, equal to that leg and square it. And so like this first one, understand, I guess this is all under understand. You've got a pretty picture. You've got your labels, and now we set it up into an equation. But now the translate and solve, to translate this, that's x squared, but this is x plus 10 times x plus 10. That's going to be a little tedious. 2x minus 10 times 2x minus 10, also a little tedious. Zoinks. So we multiply all of that out. 2x times 2x, 4x squared minus 20x plus 100. X squared plus 10x plus 100. Combine like terms. So we got these two put together. 2x squared. We got these two put together plus 20x plus 100. But it's still equal to all this stuff on this side. 4x squared minus 40x plus 100. And so now I'm going to make an interesting move. I'm going to move everything to this side instead of to this side because I want my positive x squared, okay? So I'm going to go minus 2x squared minus 2x squared. That's 20x plus 100 equals 2x squared minus 40x plus 100. Then I'm going to go minus 20x minus 20x. That's 100 equals 2x squared minus 60x plus 100, and then minus 100 and minus 100. And so after all of that, I've got this equation here. I'll write it over here. I've got 2x squared minus 60x equals 0. Okay? So now we factor out. What can we factor out? I can, because it's not perfect squares, so there's just two terms. There's a minus in between. So I'm going to factor out at 2x. Greatest common factor is 2x. This is factoring. Greatest common factor factoring is factoring. So we get x minus 30. And now we set these two equal to 0. So the 2x is equal to 0. X minus 30 is equal to 0. And so I end up with two answers. I got divide by 2. X is equal to 0. Add 30 to both sides. X is equal to 30. Well, lengths have to be bigger than 0. So this one is out because we call that a domain restriction based on like reality. In the real world, a length can't be 0. If it's 0, it's not a triangle. So the stipulation on the domain was it had to be bigger than 0. So 0's out. But 30 will work. So if I put 30 in there, that's my shortest leg. And then if I put 30 here, 30 plus 10, that's 40. And then if I put 30 there, 2 times 30 minus 10, that's 60 minus 10, that's 50. Oh, of course, a 3, 4, 5 triangle. Yep. So 30, 40, and 50 are the answers. But that was one heck of a problem. All right.